So we've been asked to determine if the function is differentiable. So we need to think about the definition of differentiability. One, we must be continuous. So we'll need to show that in order to know if we're differentiable or not. Then, we need to make sure that the slopes from left equals right. And we're going to use all of the correct notation to make sure we earn full points here. So for continuity, we're going to say, hey, does the limit as x approaches -4 minus, that's the left side, of x squared plus 16x plus 2, what does that equal? Then we'll show the limit as x approaches -4 plus, so that's going to be our 8x minus 14. What does that equal? So we've checked both sides. Both limits equal -14. But that still does not mean we're continuous until we find f of -4. Now because this is a piecewise and this bottom one is or equal to, then we know that same -46 here is also this one. But we need to state this because it's part of the definition. Now that I've shown my limit, my function are both -46, I can say we're continuous. Now, we're going to find the derivative from the left, and that's the limit as x approaches -4 minus of my f of x minus my f of -4 minus. Well, that turned out to be -46, so if I wanted to replace that with a number, I could. All over x minus 4 minus. I show all that just to show the AP board that this is the definition of the derivative from the left-hand side, so I need to take the derivative of this. So that will be 2x plus 16. When I plug my -4 in, I have -8 plus 16, or 8. Now I'll do the same on the other side. Limit. X approaches -4 from the positive side. F of x. Well, I know this function at -4 is -46. All over x minus 4 from the positive side. And that's going to be the derivative of this lower function. Well, that's just 8. And so sure enough, these slopes are equal. So I can say yes, differentiable at x equals -4. But only because I also showed that we were first continuous.